Yes, am I audible to all of you?
Yes, ma'am.
Ali, Marwa, Ubaidullah. Is it audible to others?
Yes, ma'am.
Okay. Ubaidullah, you didn't join the backup class yesterday. Aisha and Marwa did.
Yes, ma'am. Some network problem was there.
Okay, at least take the recorded lecture so that you are able to cover it, because this is completed. Once completed, we cannot do it again. So in the next backup class, we'll start with Coulomb's law, but the properties of charges and everything we have completed. So at least, Ubaidullah, take the video lecture from the Learnivio's operation team. Okay. Hey class, what all things we have completed? We have studied about the potential difference, its relation with work done, and how to solve questions related to work done. Correct. Now, class, we have a concept which is known as equipotential surface. So, what is the meaning of this equipotential surface? See, from the term if I write the term equipotential surface, it's a very easy, small topic. Like your electric field lines, it is easier than your electric field lines even. Equi means equal. And potential, we have already studied that this is the entire work done in bringing a unit positive test charge from infinity to a point and all. And surface means a plane surface. So this surface which has equal potential at all the places, this is called as equipotential surface. A very easy topic to understand. A surface, suppose this is a surface. So at every point of the surface, here if I take, let's say the potential is 1 volt. Here if I take, the potential is 1 volt. Here if I take, the potential is 1 volt. So a surface at which all the points are giving you the same exact values of potential. Like look at this. Q charge is present here inside. At this point, I have 2 volt. At this point, 2 volt, 2 volt. So the potential at A is equal to potential at B, which is equal to potential at C. Similarly, look at this. It is not necessary that this has to be a circle or a symmetrical figure. If it is unsymmetrical, random shaped figure like this, and still I am getting the potential at all the points equal, at all the places equal, single value of potential throughout. It means this surface will be called as an equipotential surface. So there are certain properties of it. First property is that, what is the definition? Like potential at every surface on the equipotential surface is the same. Okay, at every point, if you have any figure, if you have any shape, size, whatever is it, the potential shouldn't be variable. A point here is chosen, a point here is chosen, a point here is chosen. A, let's say B, let's say C. So at all the points, let's say VA, which is equal to VB, which is equal to VC, if this condition is satisfied, we can directly say the surface is an equipotential surface. All right, so first property is very easy, just the definition about it. Second property, class, tell me one thing. We have studied the definition of the work done as what? The change in potential multiplied to the charge. First of all of you open the camera. Meeting is already on the focus mode. Ali, Aisha, Marwa, and Ubaidullah, all of you. If there is any specific issue in any of the classes, just tell me prior. I'll not force you. I'll understand. But otherwise, you all have to obey the instruction. And this is not just for Aisha and Ali. So, class, change in potential. When we are talking about the change in potential multiplied to the charge is the formula of the work done. So, class, can you tell me what will be the change in potential in this case? What do you think? What should be the change in potential here? Anything you can say about the change in potential? Yes, Ali, very good. 0. See, class, when the value of potential is not changing, look, the value of the equipotential surface, in the equipotential surface, what did we study? that potential is remaining the same. If initial is also the same, final is also the same, so the change is the same. Like if I ask you to calculate, at one point I have 2 volt, at another point I have 2 volt. What's the change? Nothing. 2 minus 2, 0. So if there isn't any change in potential, no changes in potential, because your final minus initial will be, see, V final is equal to V initial. So V final minus V initial will be 0. V final is equal to V initial. So V final minus V initial is 0. That is change in potential 0. You multiply 0 with any charge, whatever charge is given, any of the charges. Straight away, work done will be 0. So class, how is it helpful to you? This is helpful in the sense that a numerical can be given to you with just a mentioning of the equipotential surface. That a surface is given, an equipotential surface has this, that, like this, a question can be constructed. So you will feel that it is out of variables. It has less amount of variables given. The values are very less. The work done isn't mentioned. How will you calculate? So if it is an equipotential surface, straight away you write the work done as 0. So this is the second property. First property is about the definition. Second property is that when there won't be any change in the potential, how will you get the value of work done? And this second point is much more important than any other point. Okay, third, fourth, let me discuss. Then I'll tell you how to draw the equipotential surface. See, when you have a plane surface, you have to relate electric field and equipotential surface. If you have a plane surface and you want to drop equipotential surface, sorry, you have an equipotential surface and you want to drop electric field onto it. So electric field will always be perpendicular to the equipotential surface. This is your surface, electric field will always be perpendicular to it. So this is how you will represent electric field. Electric field perpendicular to the plane surface. Wherever it is kept, if the equipotential surface is like this, electric field will be dropped like this. Equipotential surface is like this, electric field will be dropped like this, perpendicular. And fourth one is related to your electric field lines. If you all can relate, remember we discussed property in case of electric field lines regarding relative density. And when field lines are closely packed to each other, it shows a very stronger electric field. And when there's a gapping between the electric field line, that shows that the weaker electric field is present. So likewise, if you place the equipotential surfaces very close to each other, that represents stronger electric field. Like in this region 1 and 2 have a very less gap. In between in between them, 1 and 2 have very less gap. So this shows that, okay, if the distance is very less, it means the value of electric field is very strong. And if there is a larger gap like this, if the gap is more, so we can say the electric field's value is less. By looking at the equipotential surface, you should be able to tell or comment about the electric field also. So these are the 4 basic properties about equipotential surface. How do the questions come? One, I've already told you, in the form of numericals, it may mention you an equipotential surface. Through that, using the properties like work done is 0, potential will remain the same, they can be helpful in your numericals. One type is this. Second is a very direct basic question. An equipotential surface is important. Like, what are equipotential surfaces? Mention its properties. Other than that, third question that can come from this topic is draw the equipotential surfaces. So that we'll do separately, not under the properties, because that question I have seen much more than the properties one. So we'll practice the drawing part, that I'll tell you how you have to draw. But first, write it down. Write it down till here, all of you. Marwa and Ubaidullah, your videos are not open. While writing, if you people want to shut down the camera, it's okay. But at least after writing, when I am teaching, when it's an interactive session, just open the camera and interact. And otherwise, see, class message will be sent to your parents. So directly just obey the instructions. Ubaidullah, it's for you also.
Yes, ma'am. Ma'am, can you scroll? Finish. Ma'am,
Yes.
here electric field, why is it always perpendicular?
Why is electric field always perpendicular? See, when you drop the electric field line, see, we have studied about electric field separately, right? And we have studied about electric field lines also. So this is basically the representation of electric field. So this is this will be a part of electric field line only. So when you have a plane surface which is equipotential, means the potential is same at all the points. Electric field becomes perpendicular to it. So when you represent, that's why these lines have been made perpendicular, because these are representing the electric field lines. Okay. So when you represent the electric field lines, for representation purpose, we use the field lines concept. So that's why electric field, this is written here, it is written electric field. This means, see, when you drop the tangential to it, when you drop the tangential surface to it, this one, if this is the electric field line, a tangential surface to it like this represents the electric field. This is your electric field line. So technically, when you this is just a representation of electric field. How are you representing it? And when you want to relate electric field with the formula, we have not done a formula. You will see it later. There is a relationship between the electric field and the potential. So through that formula, it will be very much clear. That is potential gradient formula. So that we have not done right now. That will be done after we complete the dipole moment part. Okay.
Yes, ma'am. So here area vector is not required.
No, no, no. You don't require the area vector here. That is for the flux. For the flux, you require the area vector.
But for normal surfaces, electric field lines are not required to be perpendicular, right?
No, no, no. These are just for the equipotential surface. That's why it's the property of equipotential surface. Electric field will not be perpendicular to it. Electric field is just perpendicular to the surface of conductor. See what happens here. I'll just tell you a little in detail so that your doubt about 90-degree will get a little clear. When you have equal potential, it doesn't allow the charges to go inside the surface. Okay, so this is known as electrostatic shielding. So charges are just resided on the surface of it. So by this way, the surface, which is your equipotential surface, acts like a conductor. And it is found that electric field is always perpendicular to the surface of conductor. That's why here also electric field, it is written electric field line is not, it's not written lines, but electric field is perpendicular to the surface of conductor. So whenever you have equipotential, the charge, it does not allow the charges to go within the surface. So since the charges are not within the surface, this acts as an equipotential surface. So this property is called as electrostatic shielding. We'll do that in detail. Is that now clear, Ubaidullah?
Yes, ma'am.
Class done? Can we move forward?
Yes, ma'am.
Okay. All right, class. So how to draw the equipotential surfaces when you have isolated charges? How you have to draw the equipotential surfaces? Now, see, for isolated means you just have single charge present. Like, look here, this is plus Q. Let's say this is plus Q. So for positive charge or negative charge, just draw concentric circles. That's it. Okay, with equal spacing. So these just draw concentric circles like this. So it's better for these if you use compass. Evenly, you will be able to draw the circles. Also, it will be quick with, rather than drawing it free-handedly. So like this, you have concentric circles. And minus Q, same thing. This should be equally spaced. Okay, just when you draw it, right now in your rough notebooks, you can draw it like this. But when you draw it in the final exam, draw it with the help of compass. So these are separate figures. This is 1, this is 2. This is not a single figure together. Now, if you have two positive charges or two negative charges, so see class, two positive or two negative, they'll attract or repel?
Repel.
Repel, exactly. So since the charges are repelling each other, towards their centers, the charges, see, they are repelling each other. So there will be a larger gap like this. I'll show you. This is plus Q. Okay, this one is plus Q, and let's say this is plus Q. So look, here the charges will have a closer spacing, here a larger gap like this. Here again a closer spacing and a larger gap like this. Here again a closer spacing and a larger gap like this. Here, see, there will be a gap and the lines will be closely packed here till this. So close here, greater gap here because they are repelling each other. Closer here and a greater gap here like this. And same for negative. I'll just write it here. Same for negative charges. Same for the negative charges. If you have a dipole means positive and negative. So it will attract each other, right? And not necessarily just for dipole, just positive and negative also. Like in dipole, the magnitude is also same. If the magnitude is not same, still then. Unlike charges are there, they'll attract each other. So if you have, let's say, plus Q and you have minus Q. So see, to show the attractive nature, see, charges, here there will be closely packed. Here there will be a gap. Look, here the charges will be closely packed and here there will be a gap like this. Here they are closely and here there's a gap like this. Like this, okay? In the center, towards the center, just draw a closeness that is showing the attraction of the charges. Then when the electric field is uniform, you have to represent the equipotential surface. So like your electric field lines, equipotential surfaces will be placed equally and parallel and equidistant. This is the characteristic of it. It is parallel and it is equidistant. So lines are parallel and equidistant. And for non-uniform electric field, there can be any gappings. You can see here D1 is greater than D2. Like this, there can be any gapping over here. Okay, for non-uniform electric field. So these specific cases can come to you. And they can give you incorrect case out of the, and they'll give you 4 options in your section A to identify which one is wrong. Like this. These questions come from both of it, electric field and equipotential. And that's all. This is all about your equipotential surfaces. Now we'll go towards the next topic, that is, if dipole is present, how do we calculate the potential? So please write it, all of you, and you have to ask, if you have to ask anything, please feel free to ask.
These are electric field lines.
No, these are equipotential surfaces. Electric field lines, I was just saying that you can relate it. You've studied electric field line. So in electric field line also, I told you the field lines will be closely packed when you have the strength more, or when the electric field is uniform, they are parallel and equidistant. Likewise, here also you can relate it. Same thing. But these are equipotential surfaces. Okay.
But those lines are, I think, electric field.
Okay, in this case, this one.
Yes, in both.
Yes. In both of these, no, yes. These are electric field. The purple one is the equipotential surface. This one which I've drawn, this is the equipotential surface.
So when distance between them is same, then this is the case.
When the distance between which equipotential surface,
Equipotential surface.
yes,
Yes, ma'am.
then the electric field is uniform. Okay.
Yes, ma'am. Ma'am, can you scroll up?
Done. Others have also completed. Everybody?
I am
Yes.
doing. Ma'am, here are electric fields not parallel.
No, it is non-uniform. In electric field line, we discussed when you have to represent non-uniform electric field lines. They are not parallel, they are not equidistant. Okay,
Yes, ma'am.
done?
Yes,
Okay.
yes, ma'am.
Let's come to potential. See, when we have a potential due to a dipole, first understand its figure before proceeding to something. See, what it is like, basically, you have a charge plus q, understand it here and then relate it to this main figure. And the charge minus q. Plus q minus q, this is your dipole. Separation between both of it is 2a. This we already know. And a separation between the two of it is 2a. Now, so look, this is plus q, this is minus q, separation between them is 2a. So half of it this will be a, this will be a, right? Half of it. Now look, at a point P, this is a random point P that is taken. This is not axial, this is not equatorial. All right, class. Those students who are preparing for NEET or JEE separately, in your NEET and JEE batches, you will be taught about the electric field due to a general point. But potential due to a general point is there in your CBSE board exam also. So everybody has to study this one. Electric field for axial and equatorial is it. That's it. But for the NEET purpose, you will do in the NEET batch, not in this batch. Potential, if it is done here, this is for both of it. This is for CBSE also. See, this point P is there. Let's say this is making some angle theta here. Now, this is R. We always take from the center of the dipole to the point of calculation this distance as R. Now, class, this separation from charge Q to point P, I'm taking it as R1. Now, this R1 is lengthier than this. Let's say this is P, this is A point, this is O point. Okay, this PA, this R1 is greater. But what if I exceed it like this? Like this. See, now this and this, they are equal. Earlier, this R was short. Now, please pay attention, all of you, right now. Don't get distracted. Understand it properly. Otherwise, you will have trouble understanding this. See, a point P is taken randomly, which is inclined at theta angle, and R is the separation to it. Okay. Now, what is happening here? This full length is R1. The length of this is R1 and the smaller one is R. Since they are not equal, to make them equal, we extend it like this. We drop a perpendicular. This is the perpendicular. Look, AC is the perpendicular that is dropped. Now this PC and PA, they are almost equal. Similarly, when the smaller side is drawn, when this R2 is drawn, this and this becomes very lengthy. Now R becomes lengthier than R2. In the second case, in the first case, R1 was greater than R. Now they are comparable, these two extended sides. What we do, we take a point like this, we drop a perpendicular. Now this one and this one, they both become equal to each other. Come to the figure, come to the original figure back and try to understand it properly from it. What has been written? So class, here you have this figure. Plus Q and minus Q are separated by a distance of 2a. Half of them have the length AA. This point P is chosen, right? Which is inclined to sum this angle theta here. We drop two perpendiculars to make or to get the sides equal to that of R1 and R2. And why are we doing this? That I'll tell you right now. Why was there a need to do this construction? First of all, class, it's a derivation. So derivation has some fixed steps that you have to follow. Now, when this is theta, let us just calculate the potential. Let us calculate the potential due to it. Potential due to Q1, VA. Potential due to A, this will be KQ by R1, right? KQ by R1 at point P. Potential at point P due to B, it will be minus KQ by R2. Correct? Yes. This is the potential due to individually, both of it. Minus by minus K into minus Q by R2 for this one, VB. For AK, Q by R1. So what will be the net potential? Net potential will be KQ by R1 minus KQ by R2. Let me take KQ common. So 1 by R1 minus 1 by R2. Now the problem here is that this is the total answer. This is the total answer. That's it. But the issue is that small r is the known variable. R1 and R2 are the variables that I have taken. I've just marked them, both of it. How PA and PC are equal by geometry, we have constructed it. This is a construction in the derivation. This R1 was greater than R. So we have extended it so that this becomes equal. And yes, then this is an isosceles triangle. If you see this whole triangle, that will be. But see, when you are focusing on it, isosceles triangles, the other properties are also existing, okay, in the triangles. Right now, don't bring this isosceles and right angle. As soon as there's a need, I'll mention the name of the triangle. So see, the problem here at this point is that R1 and R2 are unknown. So we have to get the values of R1 and R2 first before we perform anything else. Now for that purpose, if you see here, this small triangle AOC, which we have made the construction part. This is the perpendicular AC. This is the base OC, and hypotenuse is A. If this angle, if this is theta, this will also be theta. So see, this is in triangle, in the triangle AOC. Look, the triangle is like this. This is A, this is O, this is C. This is the perpendicular, this is the angle. This is side A. If I calculate here cos theta, so cos theta will be base, that is OC, by hypotenuse, that is A. So I'll get OC equal to A cos theta. Now, why was there a need to do this? You'll understand here. Look, class, what is PC? Can I write PC, this whole big length, PC, this full length, this one, as PO plus OC? PO plus OC, right? This one. Now, PC is something like this, right? Which is not a known variable. This isn't something that we know. We just know PO, that is R. So we can replace PC with PA. PA is almost equal to PC according to our construction. We have done constructions deliberately because of the derivation. So PC can be written as PA. So I can say PA is equal to PO plus OC. Now class, PO is small r, OC is A cos theta, and PA is R1. So I get my first equation as R1 is equal to R plus A cos theta. Now at least I have the value of R1 with me. So this is the first equation. Tell me. Now this part is clear. Why was the construction done and everything? Is it clear to all of you till here?
Yes, ma'am.
Okay. So see, let's come to the other side. Now the smaller triangle ODB. Okay, I'm considering the smaller triangle in triangle ODB. Look how your triangle is. This is the triangle. This is the angle. This is the perpendicular that we have dropped. And this is the hypotenuse. See, the triangle is like this. This is the perpendicular O. This is D. This is B. This is the theta that we have taken, and this is side A. Again, if I take cos theta here, see, it will be base, that is because dB is the perpendicular that we have dropped. So OD is the base, OD by A. So OD becomes equal to A cos theta. Now come to the shorter side. Again, I can write PO as PD plus OD. PO can be written as PD plus this OD. So PO can be written as PD plus OD. Okay, PD can be replaced with PB, right? So I can say PO is PB plus OD. PB plus OD. Now class, what is this PB equal to? PB will be equal to PO minus OD. So let's see what are all these things. PB, PO, OD. PB is R2, PD, PO is R, and this OD, this is A cos theta. So we get the second equation, R2 is equal to R minus A cos theta. So we have both the values of R. R1 is also known now, R2 is also known in terms of R. First, tell me, class, this part. Is it clear, or any part you want me to, any one of you? Ali, is it clear to
Ma'am,
you? Yeah, Ubaidullah.
Ma'am.
how
Ubaid?
is PB, how is PB equal to PD?
PB equal to PD. See, this is a geometrical construction. When you derive something in mathematics or in physics, if you need something, you can geometrically construct it. So we have deliberately constructed, because we want the derivation. Na? So we have constructed this in such a manner that PB is equal to PD. See, R was greater. This PO was greater and this one was shorter. This was at least obvious, because see, when you incline something, one side lengthens, one side shortens. If I have this, if I incline it, this will be lengthier and this will be short. So in
Yes.
order to get a side equal to this, a size equal to this, like think it like this. I have this, now this is side. Okay, this is shorter. So I just take a side here which is exactly equal to it, and here at this point where the shorter one is coinciding with the longer one, I drop a perpendicular. So automatically this shorter one is equal to the longer one. Got it? It's like this is the side inclined, this is the longer one, and this is the shorter side. So we have drawn the perpendicular here, this at this point. This is the perpendicular BD. So we have intentionally dropped the perpendicular at that point where the sides are equal. Similarly, in the first case which we have done, we have deliberately extended it till that point where both of them are equal. Is it clear now?
Yes, ma'am.
Vedula? Okay. And what about others? Marwa and Aisha, you both are understanding?
Yes, ma'am. Yes, ma'am.
Ma'am,
Oh, yes, say.
how is it possible that at same time it should be perpendicular and the distance also should be same?
Sorry?
Here, like it is perpendicular also and the distance is also same. PB
This
and
is
PD.
perpendicular. BD is perpendicular. Yes. Then
And at same time, PB is equal to PD.
at the same time, PB is equal to PD. So why cannot it be? Any violation of geometry or mathematics or any rule?
It might also be possible that distance is not perpendicular.
Distance is not perpendicular or angle.
Angle.
No, see, Ubaidullah. One thing remember, whenever you have a derivation means I know the final result. I'm not solving a question. I know the final answer will come out to be Kp cos theta by r. Okay, I am deriving it. Now, whenever you derive something, there is a liability of geometrical construction given to you by default. So we intentionally, in this figure, we are intentionally dropping the perpendicular by ourselves. We are making this perpendicular. That is not given to the question. What the question says what the question said. It said that you have plus q, you have minus q separated by 2a, and a point P is taken which is inclined by angle theta, and the separation is r from the center to that point P. That's it. R1 we have dropped by ourselves. R2 we have dropped. So why are we dropping? Because it's the separation. If you join it, it has to be named something for the derivation. If I won't name this, I'll not get anything. So that's why we are naming. Similarly, you can drop a perpendicular to your, when you did the torque in electric field, that time also you had to drop a perpendicular. Or forget class 12th, class 11th you have studied, formula of torque is r perpendicular into the force. Whenever you don't have the perpendicular radius, what do? You yourself drop the perpendicular. So similarly, this is a shorter side, this is a longer side. See, it may not be very obvious through the figure because this has been free-handedly drawn by me like this only on the screen. But if you draw it a little properly with the help of scale and everything with proper measurements, see, this side is shorter, R2 is shorter, R is greater. So we just cut a point here where R2 becomes equal to R, not R, this PD. Okay, Abdullah, we have ourselves deliberately taken this. So this is not a matter of chance that this 90 degree is coming or this distance is getting equal. We have put this perpendicular, we have dropped this perpendicular in a manner in which this shortest side is equal to this shortest side. It may not be very obvious through the figure, that I understand, because it has been drawn free-handedly on the screen. But you have to understand this perpendicular is drawn, so angle will obviously be 90 degree, and these sides are equal. And one more thing, Ubaidullah, even if this is a figure that has not been drawn by me, there is no violation of the rule that the total angle is not 180 degree or something like, if there was that total angle, the sum of angle of all the triangles should be 180 degree and it is exceeding it, so something like this is not happening. If this is a perpendicular, why can't these sides be equal? Is there any justification to it that if this is perpendicular, why is PD and PB equal at the same time? It can be. You have the angle is not connected to your distance. These are distances, lengths. This is angle. Both are different. Length is meters, angle is in radian. Did you get your doubt clear,
Yes, ma'am.
Ubaidullah?
Yes, ma'am.
Okay. See, now we'll put the values of R1 and R2. So V will be KQ. Now 1 by R1, so 1 by R plus A cos theta minus 1 by R minus A cos theta. Now we take the LCM here. So this is KQ. So this will be R minus A cos theta minus. Now see, when you're multiplying this bracket here, sign will change because the negative sign is there. So minus R minus A cos theta. Okay. And in the denominator, you have R square minus A square cos square. Okay. I've just missed one step. R plus A cos theta into R minus A cos theta. Now look, R minus R will be 0. Minus A cos theta makes it minus 2A cos theta. So minus 2A cos theta divided by, plus this is A plus B into A minus B, right? A plus B into A minus B is equal to A square minus B square. So look, this can be written as R square minus A square cos square theta. Now look, as minus sign has no significance over here. It's a scalar quantity. You know, it will be negative when you have the negative charge. It will be positive when you have the positive charge. If you change the direction like minus and plus like this, what I have drawn like this, if you shift the dipole, you will get it positive. So potential will be negative for the negative charge. So you can ignore this, just put the modulus for the potential. So see, it will be K Q 2A cos theta divided by R square minus A square cos square theta. Plus, what is this? Q into 2A?
P.
P.
Dipole.
Very good. Yes, dipole moment P. So finally, the formula comes out to be K P cos theta by R square minus A square cos square theta. This is the potential due to a dipole at general point. I have not written this. This is at a general point. General point means at any angle. At a general point, which means at any angle. Okay, so this is the formula. Write it till here, then I'll discuss some more things about it. But first, at least write it. And still, if
That
you
is
have query, yeah, Ubaidullah, say
formula. Q2A is equal to P.
Q into 2A, yeah. Yeah, we have not done it together. P is charge into 2A. This is the formula of the dipole moment.
Yes. And ma'am, why is it positive
Which is positive?
for modulus function?
Modulus is positive because see, potential is scalar. So if you get negative charge, you put it as minus. If you have positive, you put it as positive. Because your dipole is present, and we are talking about dipole. In dipole, a positive and a negative charge is present together. So that's why we put modulus. You will yourself see in the questions that a negative charge is there. You will yourself put it as minus. But see, when we are talking about dipole has the magnitude. We have not done this. That's why you might be getting confused. Here you take the magnitude of the charge. So that's why we are taking the magnitude of this. So which makes this as positive. You reverse it. You will get the same derivation with the positive sign. Okay?
Why is it positive?
It is positive because we are taking the magnitude of the charge. In the formula of dipole, no, P is equal to Q into 2A. That
Yes,
Q,
ma'am.
it is taken as the magnitude of the charge. And magnitude is independent of positive, negative. Right? So that's why
Yes.
potential is not due to a charge, it is due to a dipole. And
Yes,
dipole's
ma'am.
formula has magnitude. So that's why
So
ultimate formula will also be independent of the sign. It will be having the magnitude of the charge. Okay?
yes, ma'am. Yes, ma'am.
Okay. Write it. So let's see when we have our next class, Aisha, Ubaidullah, and Marwa. Because I'll start with Coulomb's law. Lots of topics are left in your backup classes also.
Ma'am, in the second step, the V is the resultant of VA and VB.
What?
In the second step,
Here, this one.
yeah.
This is the resultant, yes, net potential. And just one more thing, when you are writing the derivations for the exam, though these things are not written in the class, every point is not written. But see, for the derivation, just try to make a habit that you write a little story in the initial of the derivation when you have it in your exam. Like, let us take a dipole with the magnitude q separated by 2a. A point P is taken with the separation R from the center. R1 is the separation of the positive charge and point P. R2 is the separation of the negative charge and point P, which we discuss in the class in the starting. So you just have a habit of writing that also in your derivations. Okay, so sometimes see the variables, or what you can do at the end. Once everything is written like this, so at the end, what you can do, like this, you can write where V is the potential, which I write with the help of arrows. In the class, I mark arrows. You don't mark arrows like this. K is the dielectric constant. P is the dipole moment like this. Just mention this, at least mention this one, this much also. You will get marks. Okay, like this and everything. Theta is any angle. Like this, have a habit of writing this story part also. And if you have time, if you are deficit of time, then write it like that. If you have sufficient time left, then write the full English sentences. And Ali, you didn't submit the second question. Why?
I couldn't do it, that's why.
Why didn't you do it then?
I couldn't do it.
Acha, you were not able to do it.
No.
Okay, I'll discuss it then. Ubaidullah has also given. Ali has given. Marwa, you have also given the integrations. One student is left from this one. Who has not given the integrations assignment? Aisha.
Ma'am, I have a test for this chapter tomorrow.
For which
I'm
chapter?
having
Potential.
Yeah.
Aisha, when you joined that time only you had a test. Again.
Yeah, we have like 2 tests for each chapter. After it's over, we have a test.
Okay, after
Like,
this also.
Mhm.
Okay. So this full chapter is coming.
Yeah.
Okay, Aisha, I'll just share on WhatsApp a PDF of the derivations of this chapter then with you. Okay. At least just go through the other derivations.
Okay.
Marva, integration one, yours is also left, no? Marva?
Yes, ma'am.
Can I scroll this? Are you all writing? Or done?
Ma'am.
Ubaidullah, you're writing?
Yes, ma'am.
No.
Ma'am, can you scroll little up?
Ubaidullah, have you written this part?
Yes, ma'am.
Done?
Yes, ma'am.
Last one. Finish.
Okay, before this can be completed tomorrow also, but the assignment. Since you all are having a difficulty in this one, let us just discuss this. Okay, see, this is the assignment, right? So this was the second question. First question, you all have done it fine. Those who have submitted, this is the second question. See, when it is 5t plus 2t dt, we did a similar question, Ali, in the class. See, 5t dt, integrating it from 0 to t plus 2t square dt, integrating it from 0 to 2. Now look, 5, this is t. T becomes t square by 2. This is 5 t square by 2 from 0 to 2. This is the A part. Plus this becomes 2t cube by 3 from 0 to 2. So this becomes 5 by 2 into 2 square. You put the upper limit minus lower limit, 0 square. Plus 2 by 3, you put the upper limit, 2 cube minus 0 cube, and then you can solve this. Okay, you'll be able to do now?
Yes, ma'am.
Coming to this B part. See, I told you in case of exponentials remain as it is. So after integrating also, this will remain e to the power x only. Just one more step is the limit step. You put the limits then. E to the power 8 minus e to the power 5. This is the answer. Okay, understood the second one?
Yes, ma'am.
Coming to the third one. For the angle I have told you, see, sin theta becomes minus cos theta on integrating limits from 30 degree to 60 degree. So let me take minus sign outside and let me put the upper limit first. So this is cos 60 degree minus cos 30 degree, like this much. This is the solution. Ubaidullah has solved this further also. Cos 60 degrees value, cos 30 degree, that also you can do. That is also correct. After this, Ali, you'll be able to do.
Yes, ma'am.
Okay. Last one is 4x cube plus 2x plus 4dx. Just multiply dx with each of them. So you get, see here, you will have 4x cube dx, integrating it from 1 to 2, plus 2x dx, integrating it from 1 to 2, plus you will have 4 dx, integrating it from 1 to 2. 4x cube is 4x to the power 4 by 4 from 1 to 2, plus this is 2x square by 2 from 1 to 2, plus 4 integral, remember integral of dx is x. So this is x from 1 to 2. 4 gets cancelled, 2 gets cancelled. 2 to the power 4 minus 1 to the power 4 plus 2 to the power 2 minus 1 to the power 2 plus 4 into 2 minus 1. Ali, will you be able to solve it further?
Ma'am.
All right. So those students who have not done, it would have been better if you would have done. We just had a discussion. And I gave the assignment of potential also. So please, class, start submitting that from the assignment. Typed assignment I have given you it. Please write this part, whatever hints part you have to write. Potential assignment also, we should discuss it in the next class. And backup students, I have given you the homework from properties of charges also. So try that as soon as you people are getting free, because now we'll have the class the next week only. So you have weekend time even if you are having tests. Or Aisha, I understand she just has the test tomorrow. Aisha, when are your tests ending?
We have it, I don't know why, but we have it every month, like 2 tests.
Okay, like a periodic cycle. So this is
Yeah.
the
Then
second
we
one.
also have a term.
Okay. So it's okay, Aisha, they will keep you engaged with a lot of practice. It's just that in your summer vacations, at least you all will be free. So in the month of your July, August, whenever you have the summer vacations in the morning, we can have 2 hours classes and we can exceed the syllabus. So then you all will be ready for your reopening of the school. But class, please, as soon as you are getting the dates of your summer vacations, please update me. The least date we'll choose where all of you will have the vacation starting. So this way your evening will also be free. I'll not take the classes then in the evening. If I take a class, 2 hours class in the morning.
Yes, ma'am.
Yeah. Okay. Okay, I shall send you the derivation also. Okay, Ali has done. Rest of you also, please share your assignments. This helps in the discussion. Now, after he has attempted, he is studying this, so it will help him. Ubaid has also attempted the assignment. Now he's seeing the solution. So whatever mistake he did, he can also see that. So class, let's meet in the next week only. From the dipole part, I'll continue. Dipole's formula we have derived, but there are some more things. Axial, equatorial, everything is left, and numericals are left. That I'll do, and relation between electric field and potential. These two topics will be dealt in the next. Okay, your time is completed.
Ma'am,
So, yeah, Ubaidullah. Just at
what
least.
is
Okay, thank
axial,
you. Yeah, Ubaidullah. Say what is
axial and equatorial?
axial and equatorial? Okay, these are some points that are chosen uh, across your dipole. So if the point is lying on the axis of the dipole, we'll say this is axial. And if it is perpendicular, we say equatorial. But it won't be clear like this. You have proper derivations in your electric field. Come in the backup classes, Ubaid. Let's see when we can arrange the next backup class, because you all should also be available. Like Wednesday, we both were free, so we had the class. So properties of charges is done. From Coulomb's law, I'll discuss Coulomb's law in the next backup class, Ubaid. So like this, we'll move progressively. That will help us remember the basics. Because see, why am I doing the backup classes in detail? Because your first 4 chapters of physics are very important. That's why I'm not hurrying up with the syllabus. We are going very slow. So in the backup classes also, they are your basics, fundamental concepts building syllabus. So that are required. Which derivation, Aisha? A potential one,
Yeah,
which we
this
did.
one. Yeah,
Okay, which
the
we did.
diagrams.
Okay, yes. So, Ubaidullah, in the class, we will discuss everything. Okay, in detail, I'll tell you. That's why I'm taking the backup classes. Otherwise, I already had taken one class, which we discussed, where we discussed everything in detail. So, I'm
But
seeing, uh, where, Aisha?
the in triangle, that one.
Here?
Yeah.
Okay. So, okay, Ubaidullah. Did you get the point? We'll do,
Yes,
we'll discuss. Yeah. Say.
so that topic will be done later. Backup classes.
In the backup class. Axial and equatorial for their electric field. Potential we'll do in the next class, and I'll explain you also. Time is
Yes, ma'am.
not left, otherwise I would have completed today. When you people are available in the weekdays or any time, because Saturday, Sunday, 11th classes are there, and then your NEET classes are there. So apart from it, nobody is there in the NEET batch from here, no? Aisha is not there, Marwa is not, Ubaid is not there. So you people must be free. Let me know whenever you have time left. All those who have completed, you can leave the meeting. Your time is up. We'll meet in the next class. Okay. Thank you.
Thank you, ma'am.